Okay, this question gives us a function f of x is 3 to the x. We want to use transformations to graph y equals f of negative x plus 4. So the first thing I've got to do is I want to construct that graph for f of x equals 3 to the x. So let's construct a table of values. To do that, x f of x. If x is 0, f of x is 3 to the 0, which is 1. If x is 1, f of x is 3 to the first, which is 3. X is 2, 3 to the second is 3 times 3 is 9. X is 3, we have 27, which we're not going to be able to see easily on the graph, so I think I'll stop there. If x is negative 1, 3 to the negative 1 is 1 over 3 to the first, which is 1/3. And if x is negative 2, f of x is 3 to the negative 2, which is 1 over 3 squared, which is 1/9. So those are 5 points. That's a pretty good start. Let's go ahead and put those in on Desmos. So we'll do that. Go ahead and graph those points. So we have 0, 1 is the first point. The next one is 1, 3. The next one is 2, 9. I have 2 more points. I'm just going to go ahead and do them in a separate row just so I can have some room to adjust these. Negative 1, 1/3. And negative 2, 1/9. We'll make them all red, I guess. So 1, 2, 3, 4, 5 points. That is the graph of f of x equals 3 to the x, which we can look at. You see that going through those points. Now, what do I want to do? What is my goal here? Remember what we're trying to graph. We are trying to graph y equals f of negative x plus 4. Now, how does that work? What is f of negative x? How does f of negative x compare to f of x? Right, given the graph of y equals f of x, y equals f of negative x is what? Is a reflection through the y-axis. I hope that's kind of obvious. I mean, what happens there? For example, if I have the point 1, 3, if I take the reflection through the y-axis, that's going to move to what? To negative 1, 3. If I have the point 2, 9, it's going to move to negative 2, 9. If I have the point negative 1, 1/3, it's going to move to positive 1, 1/3. So the reflection through the y-axis is going to change all of the signs that we have there. So our table then would be what for our reflection through the y-axis? This will give us our graph of y equals f of negative x. Negative 0 is still 0, 1. Positive 1 becomes negative 1, 3. Positive 2, 9 becomes negative 2, 9. Negative 1, 1/3 becomes positive 1, 1/3. Negative 2, 1/9 becomes positive 2, 1/9. That will be our graph of f of negative x. So let's go to our screen and do that. So we have 0, 1. We have negative 1, 3. And we have negative 2, 9. Then we have positive 1, 1/3. And positive 2, 1/9. And let's make all those the same color. They were red the first time, we can make them green, and make them what? Make them orange. Orange is a little too close to red. Change my mind. Let's make them blue. All right, so you can see reflection through the y-axis. 2,9 becomes negative 2,9. 1,3 becomes negative 1,3. That one stays put. You can see reflected through the y-axis to the other side. So if we're drawing this graph, it's going to head this way. Now that graph should be y equals f to the negative x. Y equals f of negative x. And you can see that indeed that is. And then the last thing that we need to do is we need to add 4. So we have these values here. If I want to do f of negative x plus 4, x, y equals f of negative x plus 4, I can just add 4 to all of the y values. It was 0, 1, add 4, it'll become 0, 5. It was negative 1, 3, add 4, it becomes negative 1, 7. It was negative 2, 9, add 4, it becomes negative 2, 13. It was 1, 1/3, add 4, that's 4 1/3. That was 2 1/9, add 4, that's 2 1/9. Excuse me, it's 4 1/9. And those are all of my values. So I can go ahead and plug those in, and that should be my final answer. So let's go back to Desmos. And let's put all of those in. So our original thing in green was 3 to the x. This was 3 to the negative x. Now we're going to take 3 to the negative x plus 4. So we've got all of those points. 0, 5, negative 1, 7, negative 2, 13, 1, 4 1/3. I'm not sure how Desmos handles 4 1/3. I'll just call it 4 plus 1/3. And 2, 4 1/9. 2, 4 plus 1/9. And notice those dots are all what? Those dots are all blue, which we used blue before, so maybe I should change those dots to green or something. I even change them to black because that's my final one, right? So this is my final version, are the black dots. So you can see those in terms of what that graph is going to look like. So that should be y equals f of negative x plus 4. Let's see if it is. Y equals f of negative x plus 4. Does it go through the black dots? And it sure does. And let's make that a black graph. And we can see that's our final answer. So let's turn off the other graphs. Turn off the green graph. Turn off the red graph. Let's look at our final answer and ask what the domain and range is of that thing. Again, domain, all real numbers. So for our final function, domain is all reals. Which would be minus infinity to plus infinity. How about the range? Going from what to what? Looking at our graph of our final graph after doing all those switches. The lowest gets us 4, but not quite at 4, right? It gets very close to 4. And it grows, gets as big as you want it to get. So the range would be y is greater than 4. Or round bracket 4 to, or round parentheses 4 to infinity.